is time?
A deceptively simple question, yet it is the key to understanding relativity.
In 1905, a 26-year-old patent clerk named Albert Einstein did something ridiculous. He published 3 research papers that completely flipped the table on physics and humanity's understanding of time. And the best part? He was working at the Swiss Patent Office, reviewing other people's inventions, not running a fancy lab. No PhD, no big university job, just a brain that refused to play by the rules. Those papers ended the 200-year reign of classical physics, the world built by legends like Newton, Maxwell, and Galileo. Now, Sir Isaac Newton saw time as something absolute, constant, universal, steady. When someone asked him what time really was, Newton basically said,
"I don't need to explain what time is, because it's absolute." That's some confidence right there. I kind of admire it.
But as astrophysicist Neil deGrasse Tyson likes to say,
"It's easy to know enough to think you're right, but very hard to know enough to realize you're wrong."
And Einstein? He definitely realized Newton was wrong. He looked at Newton's view of time, this smooth, steady train gliding through the universe, and basically said,
"Buddy, take your foot off that absolute train. Time doesn't run on tracks. It bends, twists, and slows down when you least expect it."
That single idea, that time is relative, changed everything. And that's exactly what we do here at DeepBrain Lab. Take the biggest, most mind-twisting ideas in science and make them simple, visual, and fascinating. So if you love understanding how the universe really works, hit subscribe, give this video a like, and let's keep learning together. All right, let's see how Einstein turned light, time, and motion into the most beautiful equation ever discovered. Einstein proved that the universe has a speed limit, the speed of light, 300,000 kilometers per second, and nothing with mass can ever reach it. To do that, you'd need infinite energy. Sorry, Elon. So Einstein thought, if the speed of light is always the same for everyone, everywhere, then something else has to give. That something was time and space themselves. He realized that all speed is relative. There's no such thing as absolute motion. It's all about your point of view. If you're driving 50 km/h and someone passes you at 100, you see them going 50 faster. Someone standing on the sidewalk says they're going 100, and another driver going the opposite direction says they're doing 200. All of them are right, no one's wrong. Welcome to relativity. But here's where it gets weird. You're sitting right now, maybe watching this video in bed thinking you're not moving. Bad news. You're spinning with Earth at 1,670 km/h, orbiting the Sun at 107,000 km/h, while our solar system zooms through the Milky Way at 720,000 km/h. You're basically on a cosmic roller coaster, and don't even get a seatbelt. So yeah, everything is moving. It's just about which perspective you choose to measure it from. Now here's the part that broke physics. If you're in a spaceship flying near the speed of light, and you turn on the headlights, you'd think the light should go faster than usual, right? Nope. It still goes exactly 300,000 kilometers. Light doesn't care who you are or how fast you're moving. It's the Devo of the universe. You move faster? Time slows down for you just to make sure light speed stays constant. The universe literally bends its own rules to protect the speed of light. Let that sink in. That means time itself slows down for fast-moving observers. If you could somehow reach light speed, which you can't, your time would completely freeze. So if you ever feel like time's flying, just move near light speed. Problem solved. Einstein discovered that space and time aren't separate. They're part of one fabric called spacetime. When you move faster through space, you move slower through time. It's not poetry. It's physics. Now, we humans like to think we can see everything, but we can't see time. That's why it's hard to imagine it bending or stretching. But it does. It stretches, squeezes, and slows down depending on how fast you move or how strong gravity is around you. Scientists proved this wasn't just Einstein's daydream. In 1971, Joseph Huffell and Richard Keating took 4 atomic clocks, set them to the exact same time, and flew them around the world on commercial jets, eastward and westward. When they compared the clocks to the one left on the ground, the flying ones had actually shifted, by tiny fractions of a second, exactly the amount Einstein predicted. That's time dilation, my friend. Real, measurable, and verified. So yes, when you're flying on a plane, your time literally runs slower than the people waiting for you at the airport. Not enough to skip aging, unfortunately. You won't land 10 years younger unless the plane really gets delayed. And you don't feel the effect because everything inside you, your brain, your heartbeat, your watch, all slow down together. If everything slows down equally, you'd never notice. It's like being in a movie that's running at 0.9998 speed. Everything looks normal. The most famous example of all is the twin paradox. 2 identical twins. One stays on Earth, the other goes on a spaceship near light speed. The space twin comes back thinking only 5 years passed. But his Earth twin? He's now decades older. Congratulations, you've time traveled forward. Just not backward, because for that, you'd need to go faster than light, and the universe has a strict no refunds policy. So yeah, every astronaut who's ever gone to space has technically time traveled by a few nanoseconds. No superhero suit required. And if you're thinking, okay, this is cool, but what's it got to do with me? Well, pretty much everything. Without Einstein's relativity, your GPS wouldn't work. Satellites orbit Earth at 14,000 km/h, and because of their speed and weaker gravity up there, their clocks tick 38 microseconds faster per day than clocks on Earth. That doesn't sound like much, but if we didn't correct it, your Google Maps would be off by 10 kilometers every single day. You'd miss your Uber by an entire city. Einstein's theory literally keeps your navigation, your phone calls, your internet, and your weather forecasts running on time. So next time your GPS tells you to turn left, thank relativity, not Siri. To sum it up, the speed of light is constant. Space and time bend to keep it that way. When you move faster, time slows down and distances shrink. And all of this is proven, not theory anymore. Einstein's special theory of relativity didn't just redefine physics. It redefined reality. It showed that space and time are one connected fabric called spacetime, a fabric that bends, stretches, and flexes with motion and gravity. And here's the wild part. This was just the beginning. A few years later, Einstein went even deeper with his general theory of relativity, proving that gravity isn't a force at all. It's just space-time curving under mass. That's the next video. And trust me, it's going to bend your brain even more. If you enjoyed this breakdown, give it a like, share it with that one friend who still thinks time is absolute, and subscribe to DeepBrain Lab for more science made simple. And remember, you can't stop time, but you can definitely understand how it bends.